Hi. So for question 5, we're told that the measure of intelligence, IQ, of a group of students is assumed to be normally distributed with a mean of 100 and a standard deviation of 15. Okay, so if we let x be the random variable IQ, we can say that x is normally distributed with a mean of 100 and a standard deviation of 15. Okay, find the probability that a student is selected at random has an IQ of less than 91. So we're trying to find the probability that x, our random variable x, which is IQ, is less than 91. Okay, so I would really strongly recommend you to draw a sketch for any of these questions. Q layer 1. Okay, so like I have here, I've drawn two normal distribution curves. Okay, the first one is our normal distribution curve for IQ. So the mean is 100. Okay, and they're asking us to find the probability that x is less than 91. So 91 will obviously fall to the left of 100. Okay, so we can plop 91 in here. Okay, we can give that a value small x, like that. Okay, so the probability of being less than 91 is obviously this green area here. What we can then do is draw the standardized normal distribution curve underneath, which has a mean of 0 and a standard deviation of 1, and we can project this observed value down to our standardized curve. Okay, and we can call this value little z here. Alright, so we know the probability of being less than z is exactly the same as the probability that we are less than 91 on our standard normal distribution curve. Okay, the probabilities are exactly the same. The green areas are exactly the same. Okay, so how do we find this little value z? Well, you should be familiar with this formula here. Z equals x minus mu over standard deviation. This is a transformation which will allow us to transform this value that we have on our normal distribution curve to the standardized normal distribution curve. Okay, so let's do that right now. Z equals x minus mu over standard deviation. X is 91, mu is the mean, which is 100, and the standard deviation is 15. Okay, plopping this into the calculator, we should get a value of minus 0.6. Okay, so we know our value z equals minus 0.6, and it's good that it turned out as a negative answer because we know it's below 0. Okay, so we can therefore say that the probability that x is less than 91 is exactly the same as the probability that z is less than minus 0.6. Okay, well, how do we find this probability now? So Q layer 3, we can pop to our tables. Okay, but unfortunately our tables haven't got negative values. Okay, so due to the symmetry of the curve, we can say that finding the probability that z is less than minus 0.6 is exactly the same as 1 minus the probability that z is less than positive 0.6. Okay, due to symmetry of the curve. And if you're not familiar with that, you can refer back to a few videos on exam solutions, how to calculate different probabilities in the normal distribution curve. Okay, so looking up this value 0.6 in the tables, we can read off 0.7257. Okay, so now this is 1 minus 0.7257. Calculating that, we get 0.2743. Okay, so we know the probability that x is less than 91 is equal to 0.2743, and we usually give these probabilities to 4 decimal places. Okay, so I hope that helped. Thank you very much.